see membranosus labyrinthis. Do you remember? You. Membranosus labyrinthis, bilateral wall, connects with the periosteum of the bony labyrinthis. Do you see vestibular wall? It do you see it is expand. Vestibular wall is expand between do you see bony spiral membrane and between do you see periosteum of the bony tube. And this wall, it is free. This will be like, do you know the balloon for the party? Color balloon for the party. Very often in the color balloon for the party is placed what? Air. If you will locate here in the balloon of the party the fluid, water, and you will press, you will get inside the mobility of the water. This, do you see, wall, it is free, do you see, it is not expand. And when, do you see, the fluid goes at first, do you see, above, and after that comes below. This is called fenestra vestibule, or this is called scala vestibule, staircase vestibule, and this is called scala tympani. When do you see, at first it goes above, through the helicotrema it comes below, and travels below, then the spiral membrane and basal wall of the membranosus labyrinthis, it pushes it. It pushes, like we push by finger the balloon, do you see? And this wall will, do you see, push endolymph. Will be mobility of the endolymph. Do you see this loop of the bony labyrinthis together with portion of the spiral membrane and membranosus labyrinthis? Listen to me. You can see this is mediolus. Do you see? Here is bony labyrinthis. This is membranosus labyrinthis. Lateral wall connects with periosteum. Vestibular wall expands between periosteum and spiral membrane. This is basal wall. Perilymph pushes basal wall. On the basal wall is placed cortive organ, which includes like hair receptors. And here, above, then it will be tinctorial lamin. It fixes only by one point, and it, do you see, hangs into the endolymph. Endolymph does, do you see, mobility of the tinctorial lamin, and it contacts with hair receptors of the cortive organ. And transforms the mechanic contact into the nerve impulse. Did you understand? And you can see from cortive organ, from receptors, begin dendrites. And they go into the space of the spiral lamin. Do you remember, do you see, from membranosus labyrinthis, do you see, will go, do you see, through the openings into the space of the spiral lamin. Spiral lamin, it opens into the longitudinal canals of the mediolus. You can see inside in the spiral lamin will be analogous of the spinal ganglion. Do you remember spinal ganglion? Dendrites come, here will be body, axons will pass through the mediolus. But if the spinal ganglion, which is placed near the spinal cord in the vertebral canal, it has globe shape and collection of the bodies which complete into the globe shape. Do you see here is tiny space which is placed inside in the spiral, do you see, membrane, because this will be very micro, very tiny ganglion which is covered by capsule like all ganglions, but it has shape like колбаса. Do you know колбаса? You don't know колбаса? Do you see? I don't know how, I forgot by English. Do you know you will go into the shop and you will find the meat, do you see, which is destroyed and completed into the long pockets.
Straight.
How?
Okay, understood.
Understood. And it will do a shape like this kalbasa. Did you understand?
कबाब टाइप का जो होता है ना कबाब हाँ बड़ा सा ऐसा लाइन में रहता है ना
अच्छा अच्छा अच्छा
वो क्या बोलते हैं बारबेक्यू तुम लोग
You
बोलते
don't
थे ना
buy
पहले बार
for the breakfast.
वो
पोटैटो ऐसे से रोल नहीं करते
No.
पोटैटो नहीं चिकन का होता है
हो गया. It's done.
But
Now I
this
understand.
this is only micro. This is only micro. It will not. It will be longitudinal pocket which has this spiral way. Do you see? And this is very micro longitudinal spiral pocket, which includes the bodies of the, do you see, hearing neurons. This will be dendrites. In this, do you see, longitudinal spiral pocket will be bodies, and through the do you see, base of the mediolus by axons through the base of the mediolus will complete the cochlear nerve. Cochlear nerve. Did you understand? Cochlear nerve is formed by axons, do you see, of the hearing neurons, do you see, which, do you see, started from cortive organ, yes, pass through the spiral ganglion where will be bodies and exit by base of the mediolus. Did you understand? My dear, in the ampoules of the semicircular canals, inside in the sac and inside in the uterus, on the internal walls are placed hair receptors. These hair receptors, they hang into the endolymph. In the endolymph, we have the special clouds which are formed by otolitis. And these clouds, there's some collection of the otolitis. And these clouds, do you see, they swim inside in the endolymph. In the ampoules, in the sac and in the uterus, we have the receptors, hair receptors. And when the cloud, do you see, comes here by changing of our position, it does pressing, which transforms this pressing into the nerve impulse. When we change position, this cloud will go out, another cloud will come to the another receptors. This is, do you see, equilibrate apparatus, do you see? And listen to me, from sac, from uterus, from ampoule, where placed receptors, will begin, do you see, by dendrites, the nerve branches. From, do you see, sac, from uterus, from ampoules, they will exit. You can see from, do you see, sac, from uterus, from ampoules, do you see, will exit these bundles and they complete into the vestibular nerve. Look please with attention. Cochlear nerve is formed by axons. Here from receptors will come dendrites. And these axons of the cochlear part and dendrites of the vestibular part, they enter inside into the internal acoustic meatus. They from inside those enter into the internal acoustic meatus. And here will be vestibular ganglion. Dendrites of the vestibular part will come to their bodies, which are bipolar cells, and here will exit axons. Outside to the brain will continue travel in the cochlear part by axons, and vestibular part, will do after ganglion also axons. We will do vestibular cochlear nerve, which will go to its subcortical centers and to its nuclei. Did you understand? Listen to me. This is, equilibrate function. From receptors will begin, dendrites will come to the ganglion, and after ganglion, where will be bodies, will exit axons.
Madam, this is scala tympani, right?
This is bony tissue. This is skeleton. Yes. Yes.
So it's scala vestibuli. This is
Above scala vestibuli, below scala tympani.
tympani. Both are present in the bony labyrinth.
My dear, I said
Scala
you.
vestibuli in the spiral.
Keep. Do you see? This is membranosus labyrinthis, this is bony labyrinthis. And this is membranosus labyrinthis, this is spiral membrane. You can see this is bony labyrinthis. It joins compactly. The whole, do you see, place above the spiral membrane and membranosus is scala vestibula. Below, I will walk by, do you see, lower wall of the bony tube. Do you see? This will be tympanic.
Oh, okay.
Tympanic staircase. My dear, if you remember, I said you, in the recessus ellipticus and recessus sphericus will be produced the perilymph, will exist by cochlear canalicule. If you remember, endolymph exists by endolymphatic duct, which ends by endolymphatic sac and is absorbed by dura mater. Listen to me, membranosus labyrinthis. This wall is lateral and it joins to the periosteum. If you remember, periosteum includes vessels and is supplied better. Yes? Because on the lateral wall of the membranosus labyrinthis is placed line, which is called red line, because it is better vascularization, better blood supply, this is the collection of the vessels. And from inside it is covered by epithelial cells. Epithelial cells which cover this red line, they produce endolymph. And after circulation, endolymph exists by endolymphatic duct and the lymphatic sac. Internal ear, it is so difficultly for the understanding of the mechanism for the production of the, do you see, sound. Listen to me. Our ear catches the sound, directs by external acoustic meatus to the tympanic membrane. Tympanic membrane by vibration pushes the malleolus. Malleolus by joint pushes the incus. Incus pushes the stapes. Stapes prominence by fenestra vestibuli into the bony labyrinthis and pushes the perilymph. Perilymph travels by vestibular staircase through the helica trema, directs into the tympanic staircase. When it passes through the tympanic staircase, it pushes the basal membrane of the membranosus labyrinthis. Basal membrane pushes endolymph. Endolymph does the active hanging of the tectorial lamin, which contacts with hair receptors and which transform the mechanic contact into the nerve impulse, which, do you see, by dendrites will go into the space of the spiral membrane, where is placed spiral ganglion. And from spiral ganglion through the mediolus to its base will complete the cochlear part of the hearing nerve. Did you understand?